So this is my demo unit for the CMAES side project. I've got my Raspberry Pi Zero there. That's my B&O 055 talking back across UART. And then I've got my scope probe here on the signal, which goes off to that switch circuit to turn on my solenoid over here. It's not actually doing the power hand drill motor, it's just way too loud, so I'm using this solenoid, which does fine enough. So we can see the switching on the scope as it goes back and forth, and I'm going to tell it to take 100 millisecond samples so it can get 10 samples from the accelerometer, and to try to maximize, that's the 1. Let's see what happens. Trying different combinations, and sounds like it's found some that make the most linear acceleration. I think it's not settling out here, probably because I have my tolerance set too low, and the measurements it's getting from the linear acceleration vary more than the tolerance amount, so it's still kind of searching around and trying different combinations. So here you can see it's sampling six possible locations at each test point. Then it adapts its covariance matrix and tries another 6. Then again selecting the best, killing off the worst, and adapting its covariance matrix again and resampling. So it's just continuing that over and over again. Now if I do a similar thing, but this time I tell it I want to do, again 100 milliseconds, but instead of a 1 I'm putting a 0 there to say minimize. And so to find the combination of PWM, frequency and duty cycle to minimize the amount of linear acceleration. Let's see what happens. It starts off trying some, but it quickly finds out that the minimum linear acceleration is really when you don't turn on the motor. Still looking around a little bit, but it's kind of settling down to a low point. Well, that's not very exciting. You notice sometimes it tries a high frequency too. It doesn't affect the solenoid.